Welcome to this explainer, where we're going to unpack the absolute powerhouse of a technology that is just completely rewiring our digital world. Today, we're diving into the source material to uncover the mathematical realities, the major architectural shifts, and frankly, the existential threats behind generative artificial intelligence. We're cutting through the buzzwords to see exactly how these systems work from the ground up.
But before we get bogged down in the heavy math or the historical timeline, we've got to stop and ask ourselves a pretty fundamental question. How does a machine actually make that leap? Going from just judging the data we give it to actually synthesizing a brand new reality from scratch.
Well, to answer that, we're going to peel back the layers. We'll look at the two faces of AI, the eras of generation, the math behind the magic, multimodal systems and agents, and finally wrap up with the risks and rewards.
All right, kicking things off with Section 1, the two faces of AI. Because to really get generative AI, you kind of need to know what it isn't.
See, there's been this massive shift in the underlying math. Traditional AI, what we call discriminative AI, it basically acts like a judge. It uses conditional probability to draw boundaries and classify things. Think of it like deciding, hey, is this email spam or not? But generative AI, it's a creator. It learns the joint probability distribution. Basically, it maps out all the internal relationships of the data so it can build something entirely new that still fits those patterns.
And when you look at the actual use cases, the difference is night and day. Discriminative models, stuff like random forests or support vector machines, they're all about slapping labels on things and predicting outcomes. But generative models, like GANs, variational autoencoders, and transformers, they are literally built for creativity. They can write text, create audio, and even whip up synthetic training data when we're running low on real-world examples.
Moving on to Section 2, the eras of generation. Because, as you might guess, this level of creativity didn't just drop out of the sky.
It actually has this wild evolutionary timeline stretching all the way back to early neural networks in the 1950s and the ELIZA chatbot in the 60s. But the real explosion? That's way more recent. In 2014, GANs hit the scene and gave us photorealistic images. Then came 2017 with the massive transformer breakthrough. And that architecture right there is what paved the way for ChatGPT and the giant multimodal models that totally took over the mainstream starting around 2022.
Okay, Section 3, the math behind the magic. This is where we get into the actual blueprints of digital creation.
So the absolutely crucial concept here is something called the latent manifold. Imagine taking incredibly complex real-world data, like a super high-res image, and squishing it down into a highly compressed, lower-dimensional mathematical space. The AI then pulls off this clever little move called the reparameterization trick. It samples random points from this compressed space and decodes them back into totally new, hyper-realistic variations. It essentially learns the mathematical vibe of a concept and just builds from there.
And this totally demystifies the so-called magic of diffusion models, the engines powering tools like DALL-E and Stable Diffusion. It's really just a two-step dance. First, the forward process. It literally takes a clear image and pushes it off that manifold by adding random noise until it's pure static. Then, the reverse process kicks in. It trains a neural network to systematically peel away that noise, learning the exact mathematical path to pull pure static back into a brand new masterpiece.
Which brings us to Section 4, multimodal systems and agents. Let's zoom out from the pure math and look at how these tools are evolving right now.
We are living right in the middle of the multimodal convergence. AI isn't just reading text anymore. It's processing sight, sound, and text all at once to reason across different formats. But the real game changer is the rise of AI agents. By plugging into external APIs, these models are shifting from just generating stuff on demand to actually taking action on your behalf. We're talking about agents planning out multi-step workflows and running live tools across the web.
But it's not all sunshine and rainbows. Jamming these modalities together creates a major bottleneck called cross-modal contamination. Because these models are basically raised on text, language is still the boss. So, if a model sees a blurry image, its strong language training might just confidently hallucinate objects that aren't even there. The linguistic biases literally hijack the model's visual reality.
And that leads us perfectly into Section 5, the risks and rewards, because we absolutely have to weigh these superpowers against some severe systemic vulnerabilities.
There's this brilliant analogy from Professor Sayed Ali Mir Jalili that hits the nail on the head. He says, imagine the internet as a giant water reservoir for AI. Model collapse is like a city endlessly recycling its own water until it tastes completely flat.
And data poisoning? That's a vandal dumping toxins into the supplies so it keeps recirculating. It really makes you wonder, what happens when the water is no longer fresh?
So, let's look at that first threat, model collapse. Thanks to a math principle called the central limit theorem, if a new AI trains on the synthetic, AI-generated junk from a previous model, it recursively degrades. It systematically forgets all the weird, diverse edge cases of human knowledge and collapses into a super narrow echo chamber. It essentially oversamples the average and loses touch with reality.
To put that into perspective, a recent study actually found that large language models are hallucinating at a staggering rate of 20 to 30% right now. Now imagine taking those massive error rates and using them to train the next generation of models. You can see how those mistakes would just compound exponentially.
And then there's the threat of bad actors intentionally messing with the system through data and RAG poisoning. Researchers found it only takes about 250 malicious documents to compromise a massive model. The sources even point to a recent $6 million PR contract signed by Israel, specifically aimed at steering the outputs of GenAI systems like ChatGPT and Gemini regarding geopolitical events. Now, purely looking at the mechanics of this, regardless of the politics, it perfectly illustrates just how vulnerable retrieval-augmented generation, or RAG systems, really are. If someone manages to slip poison data into the stream, the AI could end up compounding fake information into very real and potentially disastrous advice.
Which forces us to confront a really vital question about the long-term survival of generative AI. We know it's incredibly powerful, for sure, but it desperately needs a massive, untainted supply of original human data to actually work.
So, as you walk away from this explainer, I want you to think about this paradox. Generative AI is arguably one of our greatest technological leaps ever, giving us the power to synthesize art, code, and logic. But unless we figure out how to solve the math behind model collapse and data poisoning, is it possible this incredible engine of creation might eventually drown in its own synthetic exhaust? It's definitely something to chew on. Thanks so much for learning with us today.